Now it's time to look at another example here, where we just look at a function, a particle moving with a velocity of v equals 4t cubed I minus cosine tj. And what we want to find is acceleration as a function of time, and then a displacement from t equals 0 to t equals 3. Well, we know if we want to get acceleration, that is going to equal dv dt. In this case, it'll equal d over dt of our entire expression here. And that's going to be 4t cubed I minus the cosine of t times j. And these, of course, are unit vectors, so I'll put the head on them. So I'm going to take the derivative of this term and take the derivative of this term here. So that's then going to equal 12 t squared I. And we know that cosine derivative of that is negative sine, and we have a negative already. So this becomes plus sine of t multiplied by j. So that's all we have to do, and then we do keep them separate. Okay, that makes it pretty easy for us to do. Okay, now what about determine the displacement from t equals 0 to t equals 3? Well, we want to get delta r, and we know that that has to equal the integral of v dt. In this case, the definite integral from 0 to 3 of our function, and that'll be 4t cubed I minus the cosine of t j and of course multiplied by dt. So what we're going to do now is take the antiderivative of our function, and the antiderivative of this one is going to equal t to the fourth times I. Now the derivative of cosine is going to be equal to sine. Okay, and this time the negative will stay, minus the sine of t times j. Now, I've not put the constants of integration in there. They both would have plus c terms, because we are doing a definite integral, and I know they would cancel out. So for simplicity, I'm keeping them out. This is from 0 to 3. Okay, so what does that equal? When I plug in 3 and I cube it, I do get 81. So that'll be 81. And that would be multiplied by our unit vector I. Okay, and then minus the sine of 3. Okay, now we have to remember we must plug in 0 each time and subtract that. So when I put in a 0 for t to the fourth, I get a 0. And I plug in a 0 for sine, I still get a 0. But I'll write this anyways for clarity. So 0 plus 0, that still equals 0. So our answer then is 81i minus the sine of 3j. So that would be the displacement from time equals 0 to time equals 3. Something to get used to. You know, you're quite used to just going in a straight line. Okay, but you know, now we're going to be going x and y separately. Now, if I wanted to know the actual displacement vector, I could Pythagorize 81, okay, with the sine of 3, and then take the square root of that. And of course, if I want the angle of that, I can take the inverse tangent of sine of 3 over 81 to get my actual vector. So again, 81i is the x direction component of that displacement vector, and the sine of 3, okay, for the j is the y component of that displacement vector. And that's how it works.